In the last lecture, we have studied about balancing of a chemical reaction and limiting reagents. So, now we will learn about some different types of concentrations. That is, till now when we were talking about moles and molar mass, we were talking about the compounds in its solid state or gaseous state. But when the compound is in solution, that is, when a solute is dissolved in a solvent, then its concentration is measured in some different ways. So, we will learn about these different ways of measuring concentrations. So, we have different ways of measuring concentrations. Okay. So, we will now learn about amount in solution. Okay. So, the first point we need to know that majority of chemical reactions is carried out in solutions in labs. Okay. So, majority of chemical reactions that we carry out in labs are done in the solution form. So, we need a system to know the amount of substance present in a solution. Okay. So, we need to know the amount of substance present in a solution. So, the concentration of a substance in a solution can be expressed in different ways. Okay. So, one form is mass percent or weight percent. Okay. The second one is mole fraction. Third one is molarity. Fourth one is molality. And the fifth one is normality. Okay. So, we will learn all these one by one. So, the first one is mass percentage. Okay. So, percentage by mass is given by percentage by mass is equal to mass of solute divided by mass of solution into 100. Okay. This can also be written as mass of solute divided by mass of solute plus mass of solvent into 100. Okay. Now, we will understand this by an example. So, the question is, a solution is prepared by adding 2 grams of a substance A to 18 grams of water. Calculate mass percent of the solute. Okay. So, a solution is prepared by adding 2 grams of a substance A to 18 grams of water. Calculate the mass percentage of the solute. So, mass percentage is equal to mass of solute divided by mass of solution into 100, right? So, what is the mass of solute? This compound A is the solute here. So, mass of solute is 2 grams divided by mass of solution. What is the mass of solution? It is the mass of solute plus mass of solvent. So, mass of solute is 2 grams plus mass of solvent is 18 grams. Water is the solvent here. So, 18 grams into 100. So, 2 grams by 20 grams into 100. So, the mass of the solution is 20 grams. Okay. So, this becomes 10%. So, we can say that this is a 10% solution of substance A. That is 10% by mass. Okay. 10% by mass. So, this is the mass percentage. This is a very simple thing. Now, the second point is, the second type of expressing the concentration is mole fraction. Okay. So, what is the mole fraction? It is defined as ratio of the number of moles of a particular component to the total number of moles of the solution. Okay. Ratio of the number of moles of a particular component to the total number of moles of the solution. Okay. So, let us say solute A is dissolved in a solvent B. Okay. So, a solution AB is formed. To form a solution AB. Okay. So, A is the solute, B is the solvent. Okay. See, solution is not a reaction. Okay. We can write A plus B also. So these are not reacting, this is just a solution. So let's say the number of moles of A is equal to Na and number of moles of B is equal to Nb. So this is the solute, this is the solvent. So number of moles of the solution will be equal to Na plus Nb. Okay. Now, if we want to calculate the mole fraction of A, mole fraction of A is Xa. So, mole fraction of A is equal to number of moles of A divided by number of moles of A plus number of moles of B. So, Xa is equal to Na divided by Na plus Nb. This is the formula of mole fraction. So, this is the mole fraction of A. Now, if we want to calculate the mole fraction of B, that is Xb, this is equal to number of moles of B divided by number of moles of A plus number of moles of B. So, Xb is equal to Nb divided by Na plus Nb. Okay. So, this is the mole fraction of B. Now, we will understand mole fraction better with some examples. So, the first question is, calculate the mole fractions of solute and solvent in a solution prepared by dissolving 142 grams of sodium chloride in 3 kgs of water. Okay. So, we are dissolving 142 grams of sodium chloride in 3 kg of water. So, given mass of sodium chloride is equal to 142 grams. Okay. Let us say this is W1. Now, molar mass of sodium chloride is equal to 23 plus 35.5. This is 58.5 grams. This is M1. Okay. So, number of moles of sodium chloride is equal to W1 by M1. Okay. So, 142 grams by 58.5 grams, which comes as 2.43 moles. Okay. Now, given mass of water is equal to 3 kg, that is 3000 grams. Okay. Molar mass of water is equal to 2 into 1 plus 16, that is 18 grams. So, number of moles of water is equal to, if this is W2, this is M2, then W2 by M2, that is 3000 grams divided by 18 grams, which comes as 166.67 moles. Okay. Now we have to find out the mole fractions. So, mole fraction of sodium chloride, that is XNaCl, is equal to number of moles of NaCl divided by number of moles of NaCl plus number of moles of water. Okay. So, this is number of moles of sodium chloride and this is the number of moles of water. So, XNaCl is equal to 2.43 divided by 2.43 plus 166.67. So, 2.43 by 169.1. So, this comes as 0.01437 or this can be written as 1.44 into 10 to the power minus 2. So, this is the mole fraction of sodium chloride. Now, mole fraction of water or XH2O. This is equal to number of moles of water divided by number of moles of sodium chloride plus number of moles of water. So, XH2O is equal to number of moles of water is this. So, 166.67 divided by 2.43 plus 166.67. So, this comes as 166.67 divided by 169.1. So, this is equal to 0.9915. So, this is the mole fraction of water. So, we have discussed about mass percentage and mole fraction. In the next lecture, we will study about molarity, molality and normality. Thank you.